Hello everyone, welcome back to ptet.chemistry channel. So in this tutorial, I'll go through this work 5. This is associated with the topic called stoichiometry or the mole concept. In particular, this is work 5 that is dealing with concentrations. So these are what we call molar concentration expressed in mole per dm cube. We are specifically thinking about solution, and we're thinking about concentration of solution and how they link to mole. Alright, so there's a accompanying lecture tutorial on this, and you can browse through those lecture tutorials before you go through this particular work so that it will make more sense to you. Molar concentration simply means how much mole dissolve in 1 dm cube of the distilled water or the deionized water, giving you solution. Mole of the substance dissolve in 1 dm cube of distilled or deionized water. And then you multiply by the volume of the solution, and the volume of solution has to be in dm cube in order for the per dm cube and the dm cube to cancel out and giving you mole as the unit. Specifically, you have seen like some textbook we have written them as N is equal to C times V, where C is concentration, molar concentration in mole per dm cube, and V is simply volume of solution in dm cube. So N equal to CV is an oversimplification, which of course if you don't know how to use it in terms of the units, then it will mean nothing to you at all. Specifically, this is in dm cube, so you gotta know that 1 dm cube equal to 1000 cm cube. And as such, therefore, 1 cm cube, if you want to convert cm cube to dm cube, we divide by 1000 into dm cube. I usually never bother to convert it, except to just show that it's divided by 1000, because I can express it on my calculator later on. In this first question, we have hydrochloric acid reacting with barium hydroxide. So hopefully you can see the Ionic equation is for a neutralization, because you have an acid, which is a hydrochloric acid, and you have the hydroxide, which is the alkali or the base, and then you will get a salt and you can get water. As per what we did for Ionic equation about I would say about maybe 10 lecture tutorials ago, if you look up on balance equation and then you have Ionic equations, one of the Ionic equation is on neutralization. It's basically H plus aqueous plus OH minus aqueous, giving you H2O liquid. Whatever neutralization reaction you have, whatever acid you use, whatever base you use, is always going to come back down to this particular equation for every single neutralization reaction in the world. Every acid has H plus, every hydroxide is alkali or base. You get liquid water because the salt is going to be soluble, and therefore aqueous, they dissociate into ions. Your Ba2 plus and Ba2 plus are spectator ions. Your Cl minus and Cl minus are spectator ions that do not appear in Ionic equation. This question is more on mole calculation. So as you could see, this is how the pH of the solution changes. This is you are adding HCl. HCl is acid. So what you have initially is you have the solution in the beaker, which is alkaline initially. That is your alkali or your base in the beaker, and then you are slowly adding some acid to it, and the pH will slowly become more and more acidic. This is the point of neutralization, where the pH becomes 7 or 7.0 in this case. So that is your point of neutralization, upon which you keep on adding acid. So keep on adding acid, and therefore it becomes acidic. So keep on adding acid after it becomes neutral, so therefore it becomes acidic, and eventually after you add such a large amount of the acid, it becomes like pH 0.9. So you're looking for the value in the table where it just neutralizes all of the sample. So I already marked it with asterisk there. That is when the pH gets to 7.0, and that is when all the acid neutralizes the hydroxide present. So there's 20.0 cm cube, because this is the unit for the volume here. So there's 20.0 cm cubes already given in the question. This is just reading data processing. On to the next part of the question. They say use your answer to B to calculate the concentration in mole per dm cube of the dilute HCl. So we got to look at the point of neutralization. At the point of neutralization, all the acid reacts with the base. That was essentially what the question told you, where the volume of dilute HCl just neutralizes all of the hydroxide. So that means this equation is valid when HCl is completely reacted with barium hydroxide to give you the salt and water. There is no excess acid at this point. Alright, there is no excess of this at this point. They just react equally in 2:1 mole ratio. 2 HCl is to 1 BaOH twice because of the formula and because of the balance equation, the most common thing in your chemistry on balancing equation. So we have the mole of acid over the mole of barium hydroxide. So we will set it up just like this. It does not matter which one you got it on the top or the bottom, but I know that I want one of these and I have the information on the other one because this is neutralization between the HCl and the barium hydroxide. If you look at the information given, this is the volume and this is the concentration for the barium hydroxide. That is what you have. At the point of neutralization, you know the volume of HCl, but you don't know the concentration, but you know the volume of HCl. So that is your other thing in your mole ratio that you want to compare with. Something you know, something you want to find. Alright, so from the balance equation, here I've written HCl on top, so I gotta read the balance equation. This is what we label, and this is from the balance equation. So there's 2 HCl and 1 barium hydroxide. There is 2 HCl on top and 1 barium hydroxide at the bottom. And this is equal to the actual mole that reacted. The actual mole of HCl that reacted is 20.0 cm cubed. So there's 20.0 over 1000. So I could write like this, 20.0 over 1000. That is expressed in dm cubed. And then I have the concentration of HCl. At the bottom, I have the mole of barium hydroxide. Again, I have the volume in cm cubed. So I will express that into dm cubed by dividing by 1000 to convert cm cubed to dm cubed. And I'll multiply by the concentration of barium hydroxide, which as given is 0.0500. Mole per dm cubed times dm cubed will give me mole. Mole per dm cubed times dm cubed will give me mole. Mole of HCl that actually reacted. Mole of barium hydroxide that actually reacted. Actually reacted from the balance equation, my label. Alright? So from there, hopefully you can see that I can move this up and move this up. So my expression is going to look like this. And that's just multiplied by 1, which is itself again. So I've written quite messy here, but I'm going to I'm going to copy this down onto the page down there. So cut that. And I have all the space in the world here. So what I'll do here is I'll have concentration of HCl. I'll move this down there such that I have 2 times 25.0 over 1000 times 0.0500. Don't forget and don't be shy to use bracket. Press that into your calculator and you will get the final answer. So I get 2.5 times 10 to the minus 3 divided by 20 times 10 to the minus 3. So times 10 to the minus 3 means divide by 1000. So if you have done mathematics before, you will have understood what I am talking about. This is mole per dm cubed because this is concentration. So what I said just now, 25.0 over 1000. You will have seen in my other tutorial video, I will have started using this term, 25.0 times 10 to the minus 3. This means this thing divided by 1000. That means the same thing. Should be able to key this into your calculator very easily, just like this, divide by 1000 or times 10 to the minus 3. Make sure you are at ease keying this kind of expression, powers of 10 into your calculator, because if you can't do this well, then you have problem with physics as well as mathematics. So as per any calculation which I label, this is concentration, this is molar concentration from this equation linking volume in dm cubed, concentration, molar concentration in mole per dm cubed, giving me mole of the HCl. Hence I have mole per dm cubed as my final answer written out as part of my working there. On to the next part of the question. So we have dilute nitric acid. So again, this is a neutralization between an acid and a base or alkali, and you get a nitrate salt of this barium compound, barium nitrate, where all nitrates are soluble in water. These are part of the solubility rules as we did it in ionic equations, thinking about what kind of salts are soluble and what kind of salts are not soluble. These are all part of the syllabus, which I actually previously outlined and also show you where they are in the later topics, but we did cover it when we did ionic equations a couple of lecture tutorials ago. And of course you also produce water, of which the ionic equation is the same for every single neutralization reaction that you can possibly think of, which is H plus OH minus aqueous and aqueous, giving you H2 or liquid. This is a titration, so it's a volumetric analysis. This is 25.0 cm³ of dilute nitric acid. So I have the volume of nitric acid, I have the concentration of barium hydroxide, I have the volume of the barium hydroxide. So I have concentration, I have volume, so I can get the mole of barium hydroxide. I have the volume, but I don't have the concentration, and that is what they want us to find. They say concentration, what they meant is molar concentration in mole per dm³. So I'm going to set up my mole equation, my mole ratio essentially. So if I put HNO3 on top, not that it matters, you could have gotten them the other way around. As long as you do the math correctly, you wouldn't have gotten the wrong answer. I put this on top, so I look from my balance equation. On top is HNO3, so it's 2. At the bottom is barium hydroxide, so it's 1 in front, so it's 2 HNO3. So 2 mole of HNO3 reacts with 1 mole of barium hydroxide. This is from the balance equation. And then this is equal to, if I put on the right hand side, then this is the actual mole that reacted. These are concentration and volume. This volume is in cm³. So always keep in mind that 1 dm³, which is 1 liter, is 1000 cm³. So therefore, cm³ to dm³ is just divide by 1000. Or I can do times 10 to the minus 3. So previously I did divide by 1000 all the time. In this question, I will choose another format, which is times 10 to the minus 3. I showed it previously that, when something is divided by 1000, it's the same as that value times 10 to the minus 3. You have to get used to both things as part of your mathematics as well as physics understanding of numbers. This means 25.0 divided by 1000, because cm³ convert to dm³ multiplied by the concentration in mole per dm³ will give me the actual mole of barium hydroxide that reacted. I beg your pardon, this is nitric acid, so I don't have the concentration. In fact, that is what I want to find. This is concentration of HNO3 in mole per dm³ multiplied by the concentration. What have I done here? It's the concentration of HNO3 multiplied by the volume of the dilute nitric acid, so it's times 25 times 10 to the minus 3. Okay, at the bottom is barium hydroxide, so the concentration of barium hydroxide is given here, so that is 0.0450 mole per dm³, and this is the volume of barium hydroxide. So don't do my mistake, make sure you read through the information given very carefully. At the bottom is to do with barium hydroxide. From the balance equation is 1 mole. From the actual reaction, this is the concentration of the barium hydroxide, and this is the volume of the barium hydroxide converted to dm³. Now I want to make concentration of HNO3 the subject. So what you could do is, I guess it's probably easier if you see it this way. But ideally speaking, it doesn't matter whether I put it on the left or on the right. You should be able to do the mathematics because these are fundamental primary school as well as lower secondary mathematics, which is to do with rearranging equation. So this is my unknown. Move this up there, so you multiply by 2 over 1. Move this 25.0 times 10 to the minus 3 down here, so it becomes divided by that. I'm now ready to just put everything into my calculator and evaluate for myself a value. So 2 times 0.0450 times 34.0 times 10 to the minus 3 divided by 25 times 10 to the minus 3. I get an answer of 0.1224 mole per dm³. This answer is not appropriate given the data is the data is 1, 2, and 3 sig fig, because we don't count the 0 in front of the first non-zero whole number. This is 1, 2, and 3 sig fig. We do count the 0 shown after the non-zero whole number. This is 1, 2, and 3 sig fig. So these are all 3 significant figure data. Based on the data as well as the practical detail, what is appropriate is you cannot get higher accuracy or greater number of significant figure than the value or the data that you were given with. All right, so this is mole per dm³ because it's a concentration that we are asked to find. Moving on to the next question. So we have another titration. So this is another titration experiment. This looks a bit tricky because it looks like it comes with a graph, but this is actually an acid-base reaction, which is again neutralization. So H plus from the acid reacts with the OH minus from the base to give you the salt and the water. We have some information on the acid. So we have the volume and we have the concentration. So we have volume and we have concentration. Now we add NaOH from a burette to the acid in the beaker. We are adding NaOH. So that is why when you add NaOH, you are adding it to an acid, sorry. You adding to an acid. So the pH meter, which is basically how this pH is measured, is using a pH meter. So pH meter is like a sensor. So it's immersed in the must be immersed in the acidic solution, which is in the beaker. So what happened is you will have the NaOH being slowly added, and then the pH meter will slowly tell you that the acid is slowly being neutralized until you reach the point which is pH 7, and then you keep on adding the NaOH, and then the pH will slowly increase until the pH of NaOH, which is a strong alkali or strong base. This is around the region. This is a region of a strong acid, which is the sulfuric acid. Use the graph to state the volume of NaOH that just neutralizes all of the sulfuric acid. As you could see here, so this is what you call the neutralization point. They want the volume of NaOH, which is the x-axis. So it has to be 20 cm³ of NaOH as shown there. So it's 20. But I do not just write the whole number 20. If you think about it, they are probably ran through from a burette. Okay, so eventually you will do something to do with burette, and you will need to know that burette measures to fairly accurate volume. So there will be 20.0 cm³, because you do record burette readings to 1 decimal place in O level. All right, so this is an O level or IGCSE level kind of chemistry. You do record it to 1 decimal place for O level. So we can't just leave it at 20. We kind of have to add the 0.0 because the information told you earlier is added from a burette. Burette is a very accurate apparatus, as you will use it eventually for your titration practical experiments. Moving on, use your answer to B to calculate the concentration of the NaOH. So we know at neutralization, at this point neutralization, this is the volume of NaOH that is required to neutralize all of the H2SO4. So just now we have volume of H2SO4. We have the concentration of the H2SO4 in the beaker, for the solution, the acidic solution in the beaker. Now I have the volume, which is from the burette, from my graph, and I want to find concentration. So this is back to your mole ratio kind of question. So the mole of NaOH over the mole of H2SO4. So I hope you're getting better at this. From the balance equation, 2 mole of NaOH reacts with 1 mole of H2SO4. On the top is NaOH, at the bottom is H2SO4. Label, and then from the balance equation, and then this is equal to the actual number of mole. We are dealing with solution that have concentration. On the top is NaOH. They want us to find the concentration of NaOH. So that is exactly what we are trying to find. And what was the volume of NaOH just now? So the volume of NaOH required was 20.0 cm³. So we just copy that down here. So concentration is expressed in mole per dm³. So that's going to be multiplied by 20.0 divided by 1000. or I can just do times 10 to the minus 3, whichever one you like. Just make sure you know that 1 dm cube is 1000 cm cube. So how do you convert cm cube to dm cube? You divide by 1000 dm cube. Alright, so convert cm cube to dm cube. At the bottom is H2SO4. The information was given, so it's 0.0500. That is mole per dm cube. So I need to multiply by the volume, which is 25.0 times 10 to the minus 3 in order to convert that cm cube to dm cube. Multiply by mole per dm cube. That will tell me the mole of the sulfuric acid, because that is just how the last equation, which is to do with concentration in mole per dm cube, multiplied by dm cube will give me mole. So nothing is wrong with the mathematics as well as the unit, because that is how we do math correctly. Make this the subject, move all of this up there, and move this down there. So it'll be 2 times 0.0500 times 25.0 times 10 to the minus 3. And then what we have at the bottom is 1 times 20.0 times 10 to the minus 3. And I'm ready to just press my calculator for that final 3 marks. So they are fairly easy calculation, provided you know how to label your stuff, provided you know how to do your primary school rearrangement of equation, as well as provided you know how to key in numbers into your calculator correctly, that you will not make any mistake, as well as you know what you're calculating, which is mole per dm cube, because it's molar concentration, of which the unit is already given there. Moving on to the last question of this work, we have some iron 2 ions. So this is iron 2 ions, and you're reacting with potassium manganese 7. So all these two should make sense to you as Fe2 plus. This one might not make sense to you, but it was in the table of ions which I provided, and also I told you will be very important. Table of cations, table of anions, of which one of them will be MnO4 minus. It's called manganese 7. This is VII, meaning manganese 7 ions, and you can find that from a couple of lecture tutorial ago, as well as from your lesson notes. From a lesson notes, we actually had the list of the cations and the anions. Now, a student analyzed a sample of fertilizer. He dissolved the sample in 25.0 cm cube of dilute sulfuric acid. Titration with this particular concentration, this is KMnO4. So what other information do we have? We have the concentration of the KMnO4. So let me just use a different ink so that it makes sense. We also have the volume of the KMnO4. So we also have the volume. So it seems like we can work out the mole of the KMnO4, which is no problem, because the mole of the KMnO4 is equal to the concentration of the KMnO4 in mole per dm cube multiplied by the volume, which you need to convert to dm cube. And after having seen me how I did it in the previous part of the questions, I hope it become obvious that you just need to divide that by 1000. So I'm moving back to this format where I'm doing divide by 1000, because I just want you to get used to the idea that divide by 1000 is to convert the cm cube to dm cube. I could also do 22.5 times 10 to the minus 3, and that is exactly the same thing, mathematically speaking. So 0.0200 times 22.5 divided by 1000. Hang on, I think I pressed it incorrectly. So 0.02 times 22.5 times basically divided by 1000. And my calculator showed me 4.5 times 10 to the minus 4 mole. Your calculator will have shown you like this, or they will have shown you like something 0.0000, quite a lot of 0 and then 4, 5 at the end. If I look at my data, this is two significant figure. I look at my data given, because everything in experimental chemistry is down to the data that you're given. This is your 1 and 2 and 3 significant figure. This is your 1, your 2 and your 3 significant figure. Your 1, your 2 and your 3 significant figure. Based on the data, which give you precision or accuracy of the data to 3 significant figure, it makes no sense for you to get a calculation which is not based on the data. So I will just write it to 3 significant figure for the sake of the data itself. Alright, so this is called decision making, and you have to learn that as you do more and more practical, more and more calculation kind of question. Follow the question, follow the data given. On to the next part. So there is no balance equation here. You're not expected to write one, but they give you some information. 1 mole of KMnO4 reacts with 5 mole of iron 2. So they want the mass of the iron 2 ions. So what I can say is I will have the mole of iron 2 plus ions is to the mole of the KMnO4. Based on the information given, 1 mole of KMnO4, so my KMnO4 is at the bottom, so I just write down 1 there because it's based on the information. 1 of these reacts with 5 of the iron 2 plus, so 5 mole on top there because there's 5 mole of iron 2 plus. Now on this side is the actual mole that reacted, so on the top is the mole of the iron 2 plus, but because they want the mass in grams, so I will have mass of the iron 2 plus, and then I would need to divide by the relative molecular mass or relative atomic mass. If I think about the AR of the iron 2 plus, it's going to be very similar to the AR of the iron because the iron loses 2 electrons, and remember that the mass of electron is roughly 1 over 2000, the mass of a protons, and that means when you lose 2 electrons, they are very, very light, and therefore it's as if there's no change in the relative atomic mass at all, which I can get from the periodic table, and that's just going to be 56, I think, if I'm not mistaken. So if that is divided by 56, and then at the bottom I have my mole of KMnO4, which is from the previous part of the question, so that was already in mole. I do not need to do anything about it because this is mole, actual mole. This is mass over AR. In the case of the iron 2 plus, the AR is going to be similar to the atom because mass of electron is very, very light. Rearrange your equation, so the iron 2 plus is going to be 5 over 1 multiplied by 4.50 times 10 to the minus 4, and I'm going to move up to 56. Since I'm doing more and more calculations, I hope that you can see that I'm becoming more and more advanced and I could cut down some corners. But if you're not happy with these shortcuts and whatnot, you should really, like show all your working in full until you're comfortable cutting some corners. I said previously, all the data given in this question was 3 significant figure. So this is already in 3 significant figure. So I am happy to just leave it to 3 significant figure because these are precision. Accuracy of the answer reflects the accuracy of the data given. All right, all these concentrations and volumes were all to 3 sig fig. So what is appropriate, what is suitable as your final answer here and here will be 3 significant figure based on the data. Alright, that's it for this lecture, not lecture tutorial, that's it for this tutorial on work 5, where we deal more with more calculations involving solutions. Thank you for watching. Click the button on the bottom right to subscribe to the channel. Follow me at ptet.chemistry on Facebook, Instagram, and Twitter to get connected and drop me messages. Thank you for watching. See you in the next lecture tutorial.